50 grams of soil sample passing number 200 sieve. Place it in a cup and add 125 milliliters of the dispersing agent. In this experiment, we will use a 40 gram per liter sodium hexametaphosphate solution. Agitate the mixture until the soil is thoroughly wet. Let the soil soak for at least 10 minutes. While the soil is soaking, add 125 milliliters of the dispersing agent into the control cylinder and fill it with distilled water to the mark. Shake the cylinder in such a way that the contents are mixed thoroughly. Take the reading at the top of the meniscus formed by the hydrometer stem and the control solution. This reading is called the zero correction. Also take the reading of the top and bottom meniscus reading. The difference between the two is called the meniscus correction. Keep the hydrometer in the control solution. When needed, we will take out the hydrometer from there. After taking the reading, we will place the hydrometer back into the control cylinder. Transfer the soil slurry into a mixer by adding more distilled water. Mix the solution for a period of 2 minutes. Immediately transfer the soil slurry into the empty sedimentation cylinder. Add distilled water up to the mark. Cover the open end of the cylinder with a stopper and secure it with the palm of your hand. Then turn the cylinder upside down and back upright for a period of 1 minute. The cylinders should be inverted once in 2 seconds. Set the cylinder down and start recording the time. Remove the stopper from the cylinder. Insert the hydrometer very slowly. Take the first reading and record the time. The reading should be taken by observing the top of the meniscus. After taking the reading, the hydrometer needs to be removed slowly and placed back into the control cylinder. Take hydrometer readings after elapsed time of 2, 4, 8, 15, 30, 60, and 120 minutes, and then again at 24 hours. The following formula are used for the data analysis. Percent finer and particle diameter can be determined from the hydrometer readings. For the calculation, we need to have some standard charts and tables. Specific gravity of water at different temperatures can be obtained from this table. This table shows the viscosity of water at different temperatures. Temperature correction factor and correction factor for specific gravity can be determined from these tables. For the calculation part, we've already measured the weight of the soil. We also determined the meniscus and zero correction. The actual hydrometer reading and temperature with elapsed time was recorded for 24 hours. Corrected hydrometer reading can be obtained by applying correction factors. Percent finer can be determined from corrected hydrometer reading and weight of soil solid. Hydrometer reading was corrected with the meniscus correction only. With this, the effective depth of the hydrometer can be determined from the table showed in the lab manual. Specific gravity and viscosity of water was taken from the tables. Finally, the particle diameters can be obtained with this data. If we have the particle diameters along with the percent finer, we can plot the grain size distribution curve in the semi-log graph paper. The curves from hydrometer and sieve analysis can be combined in order to plot the full grain size distribution curve for the soil sample. Thus, the grain size distribution curve of soil samples can be determined by hydrometer analysis.